Let's first begin by fundamental quantities. So fundamental physical quantities. Physical quantities. I would explain it what it actually is. Just give me some minutes. So fundamental physical quantities, and the second type is derived physical quantities. Also, just to make sure, please carry a notebook and sorry, yeah, please make sure to carry a notebook and pen so that you can like take notes whatever I write and whatever, like not whatever, but like important things that I speak. I may not write it, but like I think it's clear. So please take notes of it. Yeah. Again, like just watching it like a Netflix video or something like that won't help you at all. So please sit with a copy and pen and take notes of the important things I speak and whatever I write down. Okay. And second thing, uh, like in later lectures we will discuss numericals as well, right? So we have to discuss numericals as well, because in the end, in exam, you have to solve only numericals. Okay, little bit theoretical questions, but like 95% of the questions are numericals. So like whatever homework I will give or whatever questions I'm going to write, and I would, when I say that take 2 minutes or take your time to solve this question, please take your time to solve this question. I would give time in the recording only. Okay, like I won't ask you to pause the recording and solve it. Okay, so yeah, make sure to like to write down everything, to solve every question, to write down everything. Yeah, so please make more emphasis on the writing part as well, not only on the theoretical aspect. So yeah, so physical quantities are of two types: fundamental physical quantities, derived physical quantities, and sometimes, like in some books, we have this as well, what we call as supplementary quantities. Okay, what are these examples, everything I'm going to discuss soon. So let's first understand the theoretical aspect of it. Okay, so like I just discussed that distance and time are physical quantities. Okay, so like there were many physical quantities, like different experiments were carried out, different results were observed, and like different properties of any material were studied, and like one by one there are many physical quantities. Okay, like distance was there, time was there, mass was there. Similarly, when we go into chemistry, then like the mole, which is the amount of substance, I would tell it a little later. So yeah, like what I want to say is that we couldn't limit, like there were exactly 100 physical quantities or 50 physical quantities. No, there were like 1,000 different physical quantities. Okay, there were many different physical quantities, so it was like not possible to like remember every physical quantity by heart. Okay, so but we observed something, that any physical quantity, like if we have any physical quantity, it can be written down in terms of some specific set of quantities only. Okay, so let me write it down. So okay, so let me explain it once again before writing it down. So what I want to say is that different experiments were carried out. Okay, different results were observed, and we found out that there were many different physical quantities. Okay, but we found a pattern that many physical quantities dependent on only some few basic physical quantities only. Okay, so let's say we had a set. Okay, let's say A, B, C, D. Okay, let's say these were the four quantities on which like any other quantity E, F, like these can be expressed in terms of only these four quantities. Okay, I hope I'm clear. So yeah, that this is like why we have separated the physical quantities into two or three different divisions, because we observed this pattern that we were not able to remember every physical quantity, and like I already told, but there was a pattern that we observed, that all the physical quantities, like they can be written in terms of only some few physical quantities only. Okay, so these physical quantities we called it as fundamental physical quantities. Okay, fundamental physical quantities, and any quantities that were derived from it. Okay, as the name suggests, that were derived from it, they were called the derived physical quantities. So like you can take colors as an analogy. Okay, so like you already know, there are basically three colors: red, blue, and green. And any other color we choose, it can be a combination of, like we can blend these colors to form this color. Okay, so it's kind of same only, like this thing is kind of same, it's a perfect analogy for it. Okay, like again we can say that like humans observed many different colors, right? But they observed a pattern, like any color they take, they can be made out of these three colors mixing in a given ratio. Okay, I'm not comfortable with the color theory and everything, but yeah, so any color, any random color can be formed by mixing particular amounts of these three colors. Okay, so we can call these three colors as the fundamental colors, and any other color derived from these colors, okay, any other color derived from these colors, this can be called as a derived quantity or derived color, whatever. So yeah, that was the like the theoretical aspect of it. Okay, so now we would let me like write down the definitions. So yeah, no need to like write this down. That was just for your better understanding. So okay, and their units as well. Let's say we will write their units as well. Okay, so as the definition says, okay, let's first understand the definition. Okay, so the fundamental quantity, okay, the fundamental quantity is an independent, okay, the fundamental quantity is an independent physical quantity. Like, I'm going very slow because I hope you are like writing with me and noting down everything. Okay, so yeah, definition says that the fundamental physical quantity is an independent physical quantity. Okay, what it says is it is not possible that it is not possible to like represent it in terms of other physical quantities of other physical quantities. So yeah, that's what the definition says. Again, let me explain it. So any fundamental quantity is an independent physical quantity. Okay, please focus more on the word independent. I would explain it as well. So yeah, it is an independent physical quantity, and what it actually means is that it is not possible to represent that quantity in terms of other physical quantities. Okay, so I think it must be clear till now. But again, like any quantity, let's say we have a quantity q, so we can't, and we have quantities like v, u, w, etc. But we can't write q in terms of any other available quantity. Okay, we can write q as q only. Then q will be a fundamental physical quantity because q is independent of other quantities. Okay, we have, if we want to write q in terms of other quantities, we can write only like this: q is equals to q. Okay, so don't on the brackets right for now. So yeah, we have to write as q equals to q only. Then q will be a fundamental physical quantity because it is independent. We can't write it, or it is not possible to represent it in terms of other physical quantities. Okay.
Lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.